Hi, we are Mission Arco from Cal State Long Beach, working on the multi-use platform at L1 project. We will launch on the Falcon Heavy, release from the launch vehicle, and Arco will fully deploy while at L1. Once we're there, we will perform refueling operations and science operations. And once propellant runs out, we will stop orbit maintenance. And on this slide, we have our customer requirements. These were derived from our project proposal. And on here, that's all. So here you can see our design for the structure, propellant storage, and refueling. In terms of our structural design, we will be using a 4 meter by 8 meter welded aluminum frame in an octagonal shape, as well as a 15 millimeter thick stuffed Whipple shield that includes aluminum, Kevlar, and polyethylene layers. For the propellant storage, we will use hydrazine fuel tanks for both refueling and station keeping, and these tanks will be designed using the COPV method. For refueling, we will be utilizing the Rafty refueling system that can refuel other spacecraft autonomously at a rate of 4 liters per minute. We will also be refueling spacecrafts with only hydrazine propellant, and this will take a little over an hour to refuel with a 250 kilogram hydrazine propellant tank. And here is a technical drawing of our current design. It is a cross-sectional view of the interior of the spacecraft, featuring our propellant tanks, the structural frame, the electronics compartment, as well as the refueling system. And on the exterior view, we can see the stuffed Whipple shield, the deployable antenna, the solar array, and the thruster systems.
Here are the components for station keeping and pointing. We're going to use star trackers, reaction wheels, and thrusters. The star trackers are going to help us know our exact position in space. This is helpful when customers want to reach us and to make sure we're on the right orbital course. We are also going to have 3 reaction wheels facing 90 degrees away from each other. This is going to allow us to yaw, pitch, and roll in space. For the reaction wheels, in order to calculate the sizing, we first calculated the perturbances in space, the momentum gain after one orbit, and the spacecraft's moment of inertia. After getting the right characteristics, we chose the right off-the-shelf components. We're also going to have thrusters that are going to help us make small adjustments to keep the spacecraft in orbit, and also are going to counteract momentum damping for the reaction wheels.